Number 15. In order for an alpha helix to span a 30 angstrom thick bilayer, how many amino acids must be in the helix? How about one beta sheet? Alright, a helix by itself can span a membrane. A beta sheet can't unless it's part of a more complex structure like a beta barrel. But we can still ask the question here. Alright, so alright, in order to answer this question, we need to recall some of our properties of secondary structure elements like alpha helices and beta sheets. So we're going to start off with the alpha helix. Alright, so one alpha helix, as we're going to see, alright, has a pitch, or alpha helix has pitch of approximately 5.4 angstroms. Alright, so that's basically for one turn of a helix is going to rise 5.4 angstroms, and each turn is going to include 3.6 amino acids. So anytime we're doing one of these sorts of problems, it's kind of a unit conversion problem or dimensional analysis problem, always start off with the number that we're given here. So we're given 30 angstroms. All right. So we want to know, first of all, how many turns are going to be necessary. So we can take that 30 angstroms, divide it by the pitch, and we're basically going to get the number of turns of that alpha helix that are necessary to span that membrane. All right, the number ends up being 5.56 turns. All right. Well, each turn now has 3.6 amino acids per turn. All right, so we want turns to cross off and give us amino acids, so we're going to do some dimensional analysis here. All right. So we're going to multiply this by 3.6 amino acids per turn, and the end result is going to be that we need approximately 20 amino acids for this alpha helix to span the membrane. All right, now if we think about a beta sheet, all right, if we go back and review, basically the distance between two amino acids in a beta sheet is about 7 angstroms, which means the distance between adjacent amino acids is approximately 3.5 angstroms. All right, as the crow flies. All right, so now if we think about our 30 angstrom thick membrane, all right, and we have 3.5 amino acids between, or angstroms between amino acids. All right. How many of these gaps are we going to have, or how many amino acids are going to be necessary? So it comes to 8.6 amino acids. All right. So we essentially need 9 amino acids to span this membrane using a beta sheet. And so you can see, because of the condensed coiled nature of an alpha helix, many more amino acids are actually necessary to span that membrane as opposed to a beta sheet.